Hey, how's it going? We are going to find the slope at a point. And this is going to sound a little bit odd because usually when we want to find the slope, we have to have 2 points to do it. So what we're going to do is take 2 points and then we're going to squeeze them closer and closer together and use what we get as we get really close together to estimate the slope at 1 point. Let me show you what I'm talking about. On the paper, we have the graph of 1/4 x squared plus 1. There it is. We are going to find the slope eventually at f of 2, which is 2f of 2. This is the coordinate 2 comma f of 2, which is really coordinate 2, 2. And so let's start by finding the slope between 2f of 2 and 5f of 5, which means that if I grabbed a ruler, we'd be finding the slope from here to here. And I want to find the slope from here to here. Now you can look through the paper and you'll see what's happening. And I've already worked it out actually. And so if you pick up your pencil and you're feverishly writing all that down, please don't ignore what I'm saying as you write. We're finding the slope between these 2 points. Okay. Pause the video and copy what you need to copy, but I'm going to keep going. I want to also find the slope from 2 comma f of 2 to 4 comma f of 4. And that's going to squeeze this line a little bit more. We're finding the slope between 2 points, but these 2 points are getting closer together. So I've just gone from the slope between these 2 points to the slope between these 2 points. Notice the answer, 1.75, 1.5, 1.25. Okay, we could probably think of a logical next answer. But before we do, let me show you what this looks like on a little more detailed and intricate level. So again, pause and copy what you need to copy. But let me show you what this looks like. This is the graph that you just saw, and it is at the point 2. This right here is where x equals 2 and actually y equals 2. This is 2 comma f of 2, which is 2 comma 2. Let me go to a standard zoom. There it is. I want to know the slope at that point. Well, I've cheated a little bit because I've gone ahead with the calculus and found that actual slope. And you can look at the graph and tell what the slope is, right? The slope of this point, the slope of this line, is 1 over 1. So rise 1, run 1. But where I'm really going with this is, well, this. Here we go. If I started there, excuse me, yeah, if I started about, let's start here. I start here, and I'm looking at this number. This is the number right here that you had on the very first problem on your paper that we just did, 1.75. I'm going to squeeze those slopes, squeeze those points together and estimate that slope, which is about 1.5 if I get it just right. Okay, let's squeeze it further. There we go, 1.25. And then now watch that number, watch this number right here as we squeeze these 2 points together. And I want to zoom in, not out. Let me zoom in, not out. Sorry, getting the wrong direction here. I'm going to squeeze these 2 points together. And as we do, we're going to estimate the slope of that blue line. Notice what's happening. Now, if I get exactly on that point, then my line vanishes because you can't figure out the slope at 1 point. But what you can do is squeeze 2 points together to get as ridiculously close to it as you possibly can. And at this point, you can look at that and say, well, I think that's going to be just 1. So the slope of this graph at that point is 1. Now, this idea of us squeezing 2 points together or finding some value that gets closer and closer and closer and closer is going to be something that we discuss a whole lot more as we move forward. It's called a limit.